Okay, so the next problem says 3 sisters have ages that are consecutive odd integers. Find the ages if the sum of the age of the youngest and 3 times the age of the oldest is 5 less than 5 times the middle sister's age. Okay, so let's go through here. The fact that we're talking about sisters and not numbers is not significant. So we just know that there are 3 consecutive odd integers. Right, 3 consecutive odd integers. Find the ages if, and then here comes the property. The sum of the age of the youngest and 3 times the age of the oldest is 5 less than 5 times the middle sister's age. Okay, so just like before, we're going to say let n equal the youngest's age. All right, then we have to be careful here because it's odd. So again, remember, if we've got odd integers, this first one is odd, and then the next one is going to be odd, but it has to come 2 after it because it's going to skip over the even. So this is the middle's age, and then n plus 4 equals the oldest's age. Okay, so let's look at the property that, or the relationship between these. So again, it says the sum of, so again, right there, that means get ready to add. So I'm going to have a blank here and add it to that. Now, it might be a sum of 3 things or 4 things. I don't know, but I'm at least going to get ready for 2 things. So it's telling me to add. What is it telling me to add? The age of the youngest, which is n, and 3 times the age of the oldest, right? So here's the age of the oldest, and I'm going to do 3 times that much. Is, right here, 5 less than, right? This is where I'm telling you it's important that we do this in the correct order now. 5 less than what? It's 5 less than 5 times the middle sister's age. So the middle sister is n plus 2, so we're going to do 5 times n plus 2. These parentheses are significant because it's 5 times this whole thing, right? And then 5 times n plus 2, and then 5 less than that, all right? If you put these in the wrong order this time, you're going to get the wrong answer. Before you would have gotten the correct answer still, but here now you will get it wrong because this is the bigger number and we're taking 5 away from it. Right, so if you reverse it, you're going to end up getting a negative number or something here. Okay, so then let's do the algebra. So again, we've got some distributive property here. We've got n plus, this is 3n plus 12 equals distributive property here. That's 5n plus 10 minus 5. All right, we combine like terms. On this side, we can add those together to get 4n plus 12 equals, and on this side, these are the like terms that we're combining. So it's 5n plus 5. Bring the 4n over. So we get 12 equals n plus 5. And then we subtract 5 from both sides. I'm running out of room here, so I'm just going to write it. And then we'll write the answer up here. So when I subtract 5 from this side, I get 7 equals n, right? So that means that the youngest sister's age is 7, and then the middle sister must be 2 more than that, or 9, and then the oldest sister has to be 2 more than that, which is 11. So 7, 9, and 11. All right, so if we check that out, the sum of the youngest and 3 times the oldest, that would be 33, is 5 less than, so I'm going to take 5 away from something, 5 times the middle sister's age, that would be 45, 5 times 9. So 7 and 33 is 40, and 45 minus 5 is 40, and we get 2 ages, or 2 numbers that are equal. So to answer their question, the sisters are, or the sisters' ages are 7, 9, and 11. Okay, let's take a look at number 4. Find 3 consecutive odd integers such that 8 more than the sum of the first 2 is equal to 11 less than 3 times the third. All right, so again, let's go back here and see what they're asking for. 3 consecutive odd integers. All right, so let's write them down. So let n, and they just call it first, second, and third, it looks like, because here they say third. So let n equal the first integer, again, we're doing odd, so we're not going to go 1 more than n, we're going to go 2 more than n. We're going to skip over that even number that's right next to it and go to the odd one. So n plus 2 equals the second integer, and then n plus 4 equals the third integer. Okay, so find 3 consecutive odd integers. We've got them ready here, labeled, such that, and here is the property that we have to have. It says that 8 more than, all right, so again, remember, when we do 8 more than, it means we're adding 8 onto something. What are we adding it on to? All right, so we did the 8 more than. We're adding it on to the sum of, oh, I've got to get ready to add 2 things together here. All right, 8 more than this sum, and it's the first 2. All right, so the sum of the first 2. All right, so the first is n, and the second is n plus 2. So it's 8 more. Right, I'm adding 8 onto something. What am I adding it on to? The sum of the first 2. So n plus 2 is, here's our equal sign, 11 less than 3 times the third. 3 times the third. All right, again, this is telling what we're taking 11 away from. All right, so it's 11 less than what? Than this. All right, so that's why the minus 11 has to come there. Okay, this is a good one. All right, let's add these two together. We get 2n plus 2 plus 8 equals, again, remember to do distributive, 3n plus 12 minus 11. We add like terms here, we get 2n plus 10 equals, we add like terms here, and that's going to give us just a 1. So 3n plus 1. I'm going to subtract the 2n from both sides. These cancel out, and I get 10 equals n plus 1. I subtract 1 from both sides. I get 9 equals n. All right, so this is our first integer. Now our second integer is going to be 2 more than that, so n plus 2 is 11. And then the next integer is going to be 2 more than that, so n plus 4 is going to be 13. All right, let's check that out. If we do the sum of the first 2, so 9 and 11, and then we do 8 more than that, is that equal to 11 less than, again, 11 less than what? It's 11 less than this, and this is 3 times the third. 3 times the third is 39. So 9 and 11 is 20, and 8 is 28. And if we do 39 minus 11, we get 28. So that works out. All right, so the 3 integers are 9, 11, and 13. Okay, thanks.